Okay, welcome you all for this new session on the new model, that is forced vibration. In the earlier class, we already studied about the classification of vibration based on the external forces, that is free vibration and forced vibration. Okay, this classification, it is based on the external force. Okay, if the external force acts on the system only at the initial time, okay, then it is called as the free vibration. If the external force, if it is continuous or if it is periodic force, then it is called as the forced vibration. After the initial force, if the body is not subjected to any force, then the resulting vibration, it is called as the free vibration. If the body is subjected to periodic external force, then it is known as the forced vibration. Okay, for the forced vibration, we already studied about the response of the system for the free vibration. What is the response of the free vibration? For the damped case, it is when it is excited, then it will have the oscillations, and the amplitude or the displacement, it goes on decreasing with respect to time, and finally it decays to 0. After some time, the displacement will be 0. It is the case for the free vibration. For the forced vibration, as it is subjected to periodic external force, there is no vibrational energy loss, so the displacements are continuous with respect to time. Okay, there is no vibrational energy loss. The body is subjected to periodic external force, so such type of vibration, it is called as the forced vibration. Okay, in this session we will study what is the response of the forced vibration for the mass spring system. It is for the single degree of freedom system. Already you know what is single degree of freedom system. It is only one coordinate is required. Okay, in the mass spring system, okay, when it is subjected to periodic external force, let us say the periodic force is F0 sin omega t. So it is varying between 0 to F0. It is varying between 0 to F0. This is the mass spring system. Okay, when it is subjected to external force, that is F0 sin omega t, so the forces on this mass are the forcing function, that is F0 sin omega t, and to resist this force there is a spring force. Okay, for the equilibrium condition, or by the Newton's second law, acceleration force is equal to restoring force, that is a spring force, minus kx, and the forcing function. Okay, you can see the spring force and the forcing function are in opposite direction, so you take it is F0 sin omega t. So it can be written as mx double dot plus kx is equal to F0 sin omega t. Okay, this equation where the right hand side it is not equal to 0, it is called as the linear non-homogeneous equation. Okay, in case of forced vibration, you already know mx double dot plus kx is equal to 0, where when it is 0 it is called as the homogeneous. Now it is non-homogeneous equation. For the non-homogeneous equation, the response of the system will be the response due to, there is two solutions now, complementary solution and particular solution. What is complementary solution? When it is equal to 0, in that case, what is the solution? That is called as the complementary solution. We already know the response of the complementary solution. It may be any function, sine function or the cos function. Okay, let us consider the complementary solution for the mass spring system. X is equal to x sine omega t plus or minus 5. Okay, so the response is okay, it is a sine function. Okay, let us find the particular solution. Particular solution means for this body it is subjected to external force, that is F0 sine omega t. It is a periodic force. For this periodic force, let us find what is the solution. Mx double dot plus kx is equal to F0 sine omega t. Okay, let us arrange it as k by mx F0 by m sine omega t. Okay, for all the terms it is divided by m. Okay, now let us assume the displacement, it is the a sine omega t and b cos omega t. So what is the velocity term? Velocity term, it is the differentiation of the displacement component. Differentiation of a sine omega t, it is a omega cos omega t, and differentiation of b cos omega t, it is minus b omega sine omega t. Okay, now again differentiating the velocity component, it is accelerating component. So it is differentiation of cos, it is sine minus sine. So a omega square sine omega t minus b omega square cos omega t. Okay, now we have the displacement component, velocity component and the accelerating component. Okay, let us substitute these displacement, velocity and the accelerating component in this equation. Okay, substituting in this equation where x double dot is minus a omega square sine omega t minus b omega square cos omega t. Okay, it is x double dot. Next, plus k by m. What is x? X is a sine omega t plus b cos omega t. A sine omega t plus b cos omega t. Okay, this is equal to f0 by sine omega t. F0 by m sine omega t. Okay, now in this we have sine components and cos component. Okay, let us separate them. What is sine component terms? Minus a omega square sine omega t, it is cos component. Okay, here sine component it is plus k by m a sine omega t, and here we have one more sine component f0 by m sine omega t. Okay, as sine it is common in all the terms, you cancel it. So by this we have minus a omega square minus a omega square k by m a, that is equal to f0 by m. Okay, similarly taking the cos components separately, minus b omega square minus b omega square, and here it is k by mb, and on the right side there is no cos component, so it is 0. Okay, now by this we can find what is b value. Okay, you take the b outside, so it is k by m minus omega square equal to 0. So bringing this term this side, 0 divided by this value, it is 0. So b value it is 0. Now let us find the a value by this equation. Okay, what is the let us take a outside, so it is minus omega square plus k by m equal to f naught by m. Okay, so a value it is k by m minus omega square. It is just rearranged f naught by m. So a value it is f naught by m minus divided by k by m minus omega square. Now let us write, we already know that k by m it is omega n square. Omega n it is the natural frequency of the undamped system. Okay, natural frequency of the undamped system. F naught by m, k by m it is omega n square and omega n square. Okay, let us take omega n square outside. So what we'll have omega n square. So omega n square it is taken outside, so it is 1 minus, okay, you divide it, omega by omega n square. Okay, now substitute the value of omega n. What is omega n? It is square root of k by m. So omega n square is equal to k by m. Omega n square value it is k by m. K by m, 1 minus omega by omega n square. This is equal to f naught 1 minus omega by omega n square. This m and this m get cancelled. So a is equal to f naught by k into 1 minus omega by omega n whole square. Okay, this is a value, and b value we already know it is 0. B value it is 0. Okay, now we know what are the constants in the assumed displacement function, that is a sin omega t plus b cos omega t. Okay, substituting this, it is a value it is f naught by k 1 minus omega by omega n whole square into sin omega t, and b value it is 0. 0 into cos omega t, 0. So x value, okay, it is for the first vibration, that is f is equal to f naught sin omega t. So this is the particular solution. So the total solution, that is complementary solution and particular solution. Complementary solution it is same for all the systems, but particular system it is depend upon the forcing function. What is the forcing function for the given body? Okay, xc, what is the assumed complementary function? It is x sin omega t minus phi. X sin omega t minus phi. And particular solution it is f naught by k 1 minus omega by omega n square into sin omega t. Okay, this is the solution of the forced vibration, single mass spring system of the single degree of freedom system. Okay, here in this this is the displacement at any time t. The displacement can be calculated here. We can neglect this value because after certain time the amplitude, this is because of the initial disturbance, it will decays to 0. It is very soon this value becomes 0. So the response of the forced vibration, it is entirely depends upon this value. So x is equal to f naught sin omega t by k 1 minus omega by omega n square. Okay, this is the response of the mass spring system when it is subjected to forcing function, or when it is a forced vibration. Okay, thank you.